Hello guys, welcome back to our channel. Remember we are discussing on operators in Java programming, how these operators works, and we have different categories of operators. We have looked into arithmetic operators, logical operators, relational operators, and now we are going to look at the last but not the least of the operators. And these operators is called bitwise operators. And bitwise operators or bitwise operations in Java is usually carried out operations on an individual's bit of data types, such as if we talked about bits of data types, we are talking about the short, we are talking about the byte, we are talking about the int, we are talking about the integer themselves and the character. These are the data types in which these bitwise operations carried out its functions, and these bitwise operations is functions according to the low level programming languages, that is in forms of zeros and ones. Whenever you issued an input, it will first of all try to convert it into a binary of numbers and then see how it can be able to manipulate with such operations. So we are going to have a quickly recap of our binary numbers ranging from 1 to probably 30, and then we look at how we can be able to now manipulate these binaries using our bitwise operation, where we are having AND bitwise operation, we are having O bitwise operation, we are having XOR bitwise operation, we are having exclusive O bitwise operation, we are having shift left bitwise operation, we are also having left shift bitwise operations. Don't skip this video. If you're just joining us onto this channel, do give us a subscription, like, share our video, and also don't forget to hit the notification button so that whenever we post our video, you can be able to have it at your fingertips. So let's have a recap of what we are doing. Let's say we have decimal, then we have binary. If you do remember your general mathematics, so if we have 1 here, then definitely here is going to be 0, 0, 0, 1, right? So, and also if we are having 2, it's going to be 0, 0, 1, 0. If we are having 3, it's going to be 0, 0, 1, 1. You do remember? So if you also have a kind of 4, it's going to be 100, which is 0, 1, 0, 0. And then if you are going to have a 5, it's going to be 0, 1, 0, 1. Right? So please, this is how we are going to be writing these decimal places versus binary numbers. So you can get them down on your own. This is how we'll be writing and then shifting these numbers. So we are going to quickly move into our bitwise operators. And we said bitwise operators, we have, from why I stopped at 1. Initially I said I will stop at 30. It will consume a lot of time. 1. 2, since we are not driving them, there is no need. So in our operations, we are going to just stick at 5, right? So this is what we want to do so that we can be able to achieve something. It cannot be a board class. So we are in number 1 of the bit operators or bit operations. We are having AND operations or bitwise AND. It's called, let's have it here. We have bitwise AND, O is represented by single ampersand, right? So here, what this bitwise AND does is just like our logical operators. It tries to compare two given input. If the input is 1, so it will return the value of 1. That is if both inputs are 1. So otherwise, it will return 0. Let's assume we want to give 5 and then what? And then 3. or 3 and 5. This is what we want to do. Our 3, we have 0, 0, 1, 1. Then in our number 5, we have 0, 1, 0, 1. So here, if you are going to give, the output of this is going to be 0, 0, 0, 1. So definitely this output is going to be 1. So let's look at this code on the board so that we assumed we are done with our public class and then the main method. All we need to do is to have our declaration and initialization. And we said these bitwise operators carried out operations on a bit of a data types. So now we declare this, we need more space. We declare this int of x as 3. We and again we declared our y as 5. So this is what we are trying to do. Then we declared our z. Our z is going to be what? It's going to be x and then y, right? So that is our z, our z, and our z also is going to be int. Please don't get confused. I forgot to declare this earlier, so I would shift a little bit. Int z is equals to x and y. So the operation we have carried out here, this is what this system is going to carry. So the only thing, if you are coming to perform your system dot out dot print, so you are going to have your printing z. So if you print z here, and your output is definitely going to be 1. So this is how we achieve our AND operation. So going forward, we have also bitwise O. Bitwise O is represented by a single vertical line. So in bitwise O, you remember either of the input is 1 is going to give you an output of 1. So that's what your bitwise O does. So what you're going to do here, assuming you have the same thing, you have 5, or let's just use this. Is it okay to use this, right? So here, when the outputs are equal, it's going to give you 0 of this, and this also is going to give you 1. This also is going to give you what? A 1, and then this is going to give you 1. That is, you have 1, 1, 1. Let's check our variable operators, our binary operators. This is how it will go. Either the output is 1 or the input is 1. Is either of the input is 1 is going to give you 1, right? So having this in mind, we don't have the operations here, but if you continue to loop, the next one you are going to have, if it is 6, let's say we have 6 here, is going to be 0, 1, 1, 0, and 7 is going to be 0, 1, 1, 1. So here the output is going to be 7. Please don't get confused. The only thing, get your data sheet of the binary numbers. Once you have the binary numbers, if you try to perform this manipulation, whatever the result is going to be, definitely what you're going to have here. So here also, if you are going to have a kind of, here we are changing this to vertical O, and then we are printing this, so the output is going to be 7. Are we together? Is going to be 7. So this is how we perform, or we conduct this bitwise O. Are we following? So the next we are going to look, aside bitwise O, we are going to look at bitwise exclusive O. Bitwise exclusive O, which is represented by this, and this is called current return. On your computer system, if you want to achieve this current return, you press your shift and 6. So this current return is located on top of a 6 key of your the QWERT keyboard of a laptop. This is where you can be able to locate this exclusive O. So what this Bitwise exclusive O perform? It usually perform a logic's exclusive operations on each pair of a corresponding bits. So the result of this is going to be 1 if the bit is are different. Are we together? If the bits are different, it's going to be 1. But if the bits are the same, it's going to be 0. Are we together? So here, if we are performing this on exclusive OR, all you need to remember your logic circuit you are done with this bitwise operations, please. So let's assume we have 5 exclusive 3, right? So here we are going to have something like 0, 0, 1, 1, right? Then we have 0, 1, 0, 1. So what is saying here, if this is the same, it's going to be 0. If this is different, it's going to be 1. This is different, it's going to be 1. This is the same, is going to be 0, right? So definitely the answer to this is 6, right? The output to this is 6. So if you're having your int, assuming you have declared this, so the only thing you declared, let's assume you declared another variable called exclusive or so you cannot use this function. Let's just use x as our new variable. Then we now assigned a variable of x, then exclusive or y. Then we now system dot out dot print. Next line, we are going to print x, which will return the value of 6. So that is the outcome of these exclusive or bitwise operations in Java programming. The next is going to be bitwise not. So in bitwise not, let's assume we'll be using only system.out.out, or if we go back to our system, we use that. The next is bitwise not, which is represented by a symbol called tilde. This symbol is called tilde. This one is carried return. This one is ampersand. This one is vertical bar. And to achieve this, we know how to do it. We don't have problem. This current return, we said you locate where 6 is. If you're using QWERT keyboard of a laptop, shift plus that 6 is going to give you the current return. Vertical bar, we said you look on top of this of your enter key, you will see a backward slash there, and then you press your shift plus the backward slash. You will now achieve this vertical bar, until you achieve it by pressing your shift plus 1 on some keyboards. So this, what usually the bitwise node does, is usually perform the functions of a NOT get. That is going to give you, or it's going to flip the result, that is the inverse of whatever you are having. Are we together? So assuming if we are having to say, let's say which one will not give us a headache here. Let's say we are having 6 or that 5, right? We are having 5. This 5 we know is going to have a 0, 1, 0, 1. So if we are now having a bitwise not operation of this 5, is going to be 01010. So with this, you see which binary numbers are we having here with that? This 1010 is going to be 20. So definitely, if you're printing exclusive or of this, sorry, not of this, definitely is going to be, let's say, XX, and you're having your tilde of y is 5, of y, then the result of this XX is going to be 20. So this is how you achieve this bitwise knot. So the next is going to be shift or left shift bitwise operations. Left shift, we call it left shift sometime like this, or you can write it in full, which is denoted by double less than sign. So what this left shift does is shift the bits of a numbers to the left, the bit of a numbers to the left by a specific number of a portion. It depends on a portion that is given to him. But no matter what, is shift from right to the left. Are we together? So before we move to the right, right shift. So in the right shift, is shift from left to right. In the left, from right to left. So zeros, usually in this operation, zeros are added to the rightmost, right? Zeros are added to the rightmost, and it now being pushed over by the numbers you are going to have on this. So this is equivalent to multiplying the number or the numbers by 2 raised to the power of n, where the n is the number of the shift. So is assuming here, if we are shifting for 3, right? If this, we are shifting for 3 by 2, right? We are shifting for 3 by 2. Let's say we have another data type where we say int our zz, that is zz is equals to let's say 3, right? 3 is x, and then we use shift 2. So here we are going to shift, where is our 3? We are going to shift this by 2. So definitely it's going to be we add 0 here, 0 is added, 0 is added. So this is move, this is move, is going to return to 1010. This is how this going to be. It jumped by 1, right? And this one is returned here, 0 is added, right? So if we, that is for the first time. For the second time, 0 again is added. This now will now shift back to this, right? Then our 0, our 1 again will now shift back to this. Then our 0 will still take place of this. So this is how these shift bitwise operations works, from right to left. So if we are talking about left to right, right? From left to right, that is right shift, which is represented by double greater than sign. So here, if we set int x, y is equals to x greater than 2. So it's going to shift to the right by 2, from the left to the right by 2. Assuming here we have, initially we have our tree as what? We have our tree as 0, 0, 1, 1. So if we are shifting this by 2, that means the first time this 0 will shift, this one will take place here. Are we together? So the next time again it will shift. So it will end up going to be 1, 1, 0, 0. So this how you now going about conducting your bitwise operations in Java. Please don't get confused. Just make sure you pause this video, jot down what we are doing on board. We are going back on the system to see how we will be able to achieve all these things that I've been saying on the board. So what we are going to do now, we need to create our file. We move to new. Sorry, we move to new. We move to class. Then we have Bitwise op, right? So we have our public class finished. So we are going to declare two variables in the first place, which is going to be what? Is going to be int x, which is going to be our tree, comma, then we have y, which is going to be 5, semicolon. This is done, right? So if we want to perform the first operation, that is AND operation, so we declared our AND operation. Let's use ABCD for all these results. Int a equals to x, and then we have ampersand y, so we have our semicolon. So we now use our system dot out dot print dot print is going to be, let's assume we have a, right? So we end this statement. So we run this and compare it to the output we've given. You see it's 1, and if you look at the output we have given, the earlier one is also need to be 1, right? So if it is not, we've seen how this works, but I believe this is what we've been able to achieve on the board here in the first instance. We have 1, though we have wiped this, and then that's it. So and then we can be able to say, to fine tune this and say we are giving it a form, the result of and of bitwise and, right? Bitwise, sorry, bitwise bitwise and is, so we concatenate this, we have it like that. So we run it again and we see that this is what we are having. The result of bitwise and is 1. So now let's go back again and say int we have b as the container of x or what, or y, right? And here if we said we are going to have system.out, that is the result of bitwise o is, let's use b here, then we run this and see, we said earlier is going to be 7, right? And it is 7. So you've seen now how you can be able to do it. We said this work on the principle of low level programming language, that is in form of ones and zeros, how you can be able to join them together and come up with your results. So again we move, we said let's have a space here for clarity. Oh, it's not here. I want to print it somewhere here. So int c is going to be x exclusive, that is after o is exclusive o. Exclusive o is being represented by caret return, right? Let's say y, something like this. Is it okay? With the reverse is the case. Let's see. We set the result to that. I think we said it's going to be 20, but let's see. Bitwise ZOR, right? Exclusive or which is C. We said we want a clarity here, so we run this, and what do we have? It's going to be 6. So what if we set y, and though this is the answer, I remember somewhere here, you see, somewhere here is 6. So this is also achievable, and we have achieved it. So let me do the other way around and see. It's going to be the same thing, no difference, right? So great. And so the next one we are going to have is going to be, after exclusive or, is going to be bitwise not, right? If in the bitwise not we have int d is equals to, that is our not, sorry, that tilde is not on 1, it is the key before 1, where you are having like a single quote, right? Before 1, this is where you are going to see your tilde. So tilde of what, of x, right? So now we want to have it here, and then this is for the d, that is for not, right? So this is what we have again, -4. But is it for y? We didn't get -4 before. Let's say for y. Yes, for y. We did for y. And -6. So we did not, on the board, we did not get this right. So, but notwithstanding, we have understand how it's working. This just giving the inverse of what we are trying to do. And so the next is going to be shift left, right? So in the shift left, let's assume we have int, we said e is going to be, we use 3, right? That is x, and then shift by 2. So we are coming to this and then print for, that is left shift now. Left shift, we are printing for e, and we said it's going to be what? Let's see, does it match 12? So this also, we did not get that binary numbers with exercise on this shift bitwise left. We did not get it there, right? That is the binary placement. So, and then just remember that you're shifting from right to left by adding zeros at the end of each uh, binary numbers given. So again, we move and set for f, int f is equals to x, then we shift by 2, then we now call for f printing, right? We call for f printing, and this time around is going to be right shift, and then we run this. So it's going to be 0. Ha, hilarious. So this is how we've been able to achieve our bitwise operations in Java programming. Bitwise operations is based on low-level programming language that it carried out its operations on a bit of a data types, including int, long, byte, and a character. So this is how we achieve this, and I believe this is also as self-explanatory, though it's little bit scary and hard than any other operators we have in Java programming. And this took you to the last part of operators in Java programming. Next, we are going to discuss or see how we can be able to accept input from the user and then manipulate to give out the output to the user. That is, we are going to use what we call input scanner function, or what we call input functions in Java programming. Stay tuned, don't be left out, stay on this channel. Don't forget to hit the notification button so that whenever we upload our video, you can have it at your fingertip. Thank you, remember less.